Today I want to discuss pointers. So when we want to define a variable, we can say, for example, int space x. This means I have like an integer variable x. If I say x equal to 100, cout x. And if I run this project, I need to include using namespace st. If I say x is 100 and I display x and I run my project, it displays 100. In this example, I'm defining an integer variable. I'm initializing it with 100, then I'm displaying it. So if you want to define a double variable, we can say double q equal to 2.1. So if I say cout x, cout q, it will display the value of q, which is 2.1. If you want to define a pointer, first we need to specify data type. If I say int star r, this means r is a pointer variable. When you define a variable and you put star, we have defined a pointer variable. So pointers, they could hold addresses. In this example, I create another variable s, and I put 100 inside s. This means s is equal to 100. I could say r equal to ampersand s. This means r has the address of s. If I say cout r and I run it, my program displays 0x7ff. So 0x means it's hexadecimal. This is the address of the variable s. So cout r will display the address of s. Since s is an integer with ampersand, I can get the address of that integer and I can display it. So we could say the pointers, they can hold addresses. In this example, pointer r is holding the address of variable s, which is an integer. We could define pointers of different types. For example, I can define a pointer of type double. I name it I. I is a pointer that points to a double. If I define double h equal to 2.1, I could say I equal to ampersand h. I has the address of h. If I say cout h, it will display 2.1. If I say cout star I, it will display 2.1. But if I take the star out and I display I, it will print 0x7 something. So this I is a pointer, but I as the address of H. When you have a pointer that points to a double, it has to store the address of a double. This ampersand means address. Address of H will go into the Y. You could have pointers of any type. Like you can have a pointer to a character. In this example, O is the pointer to a character. So if I have character T equal to G, I can say O is equal to ampersand T. If I see out O, it will display G backslash 267 and some other characters. If I say cout star O, it will display G. So star is indirection operator. It means print what T is pointing to. It means this star will take me from a pointer to what that pointer is pointing to. So we could define pointers like this. We could have pointer to any data type. We could even have pointers to classes and structures. So I want to define a function here. I type void swap int star x int star y. In this example, I have defined a function. This function takes two different pointers. Both of them are pointers to integers. I could define an integer g. And when I say g equal to star x, it means g has the content of what pointer x is pointing to. So I can say star y equal to g. So if I have x and y and I want to swap them, I can use a temporary variable. I name this temp. If I have a temporary variable, I want to swap x and y, I can keep that, the first one in the temp. And then I put the second one, which is y, inside the first one. And then I put the temp in the second one. So if I create a temp variable and I store the first one, so if we have 10 and 20, and I put a temp equal to if I put 10 inside the temp, then if I put second one, which is 20 inside x, star x will become 10. And then I put second one, the temp, star x becomes 20. And then I put temp inside the second one. It means y star y becomes 10. So by writing this code, I can use a temporary variable and I can exchange x and y. Let's try this. I define two different numbers here, int x. I take out the x from here. I define int x equal to 1 and y equal to 2. I call swap. I pass address of x and address of y. So I call my function swap. I pass ampersand x and ampersand y. I'm trying to swap x and y. I say cout x is and I run it. So when I run my project, x is 2, y is 1. So I have created the function, which this function takes a pointer to integer, a pointer to integer, another pointer to integer. I'm using a temporary variable to swap x and y. Now I want to discuss arrays. If you want to define an array, you can say int p4. This is an array of 4 integers. I can use a for loop for int I equal to 0, I less than 4, I plus plus. I can say cnp I. So if I run this code, I can put 1, 2, 3, 4, and I fill my array. So if I use the same code here, I can say cout pi and I run it. So if I put 1, 2, 3, and 4, my program will display 1, 2, 3, and 4. I have defined an array of 4 integers. But there's a relationship between arrays and pointers. So I want to show you guys what is that relationship. If I want to define a pointer, I can say int star y. We can see y is a pointer to integer. When you have a pointer, let's change this to j. We say j is a pointer to integer. When you have a pointer, pointers, they can hold addresses. So in C++, we can use the new operator to allocate memory. When I say int star j equal to new int, I have allocated an integer variable and I is pointing to that int. So the new operator will allocate memory, which is type of integer, and j is a pointer to an integer that the memory is allocated now. So if I say star j equal to 200, and I say cout j is equal to, and I say star j, if I run this, it displays J is equal to 200. So in this example, I have created a pointer. I have allocated integer. I'm putting 200 inside that integer, and then I'm displaying it using dereference operator. And then it's displaying 200. This is dereference. So this is indirection operator. This star, we call it indirection operator. This process is called a dereferencing. So I'm displaying the content of J, which is 200. Now, when you have new, you can also use delete. I can say delete J. So with new, you can allocate memory. With delete, you can deallocate memory. In this example, this delete will deallocate the memory. So I showed you guys how you can allocate memory for one integer. Now if I say int u, int star u equal to new int. If I open a bracket and I put 4, it means I'm allocating memory for 4 integers. So when I have a memory for 4 integers, I can use a for loop. I can say for int I equal to 0, I less than 4, I plus plus. I can say C and double right arrow, star, open parenthesis. And then I put the U here and I put plus I. If I use the same for loop here and I say cout, double left arrow, let's try this. If I put 1, 2, 3, and 4, it will display 1, 2, 3, and 4. If I put 1, 2, 3, and 4, it will display 1, 2, 3, and 4. In this example, I have allocated memory for 4 integers. And I'm using star. And I use the pointer, which is the U. And every time I'm adding I to it. So this means star, when the I is 0, this will be star U. This star will take me from that pointer to what that pointer is pointing to, which is the first element inside the array. And then I add 1 to it, it goes 1 forward, and then 2 forward, and 3 forward. So with this plus I can keep adding to my pointer, and I can go to the next one and next one, and then I can fill this dynamically allocated array of integers. So with new, you can allocate memory. With delete, you can deallocate memory. If I say delete, open close brackets, and I put U, I can deallocate the memory. So I did allocate them here. This is memory allocation. And this is memory deallocation.